Welcome back to AutoCAD Session 2. So we learned the rectangular array. So now we're going to do something different. So this is going to be the path array. It's kind of like rectangular array where you just make a lot of copies, but in this case it's going to be parameterized by a path. So let's see, what do I mean by that? I'm going to start by this exercise over here. So I'm going to try to make that exactly using the P line. So PL for short. It'll be 31.0499. It's going to go up 37.5192, 19.1076, 58.9897, 80.3389, 30.5792, 36.2611, and 17.566. Okay, so it should look like that. One object. I'm actually going to make a copy of this really quick, just for demonstration purposes only. So we're going to learn something called the spline. We're not exactly going to use this spline very much for Bridge Team, but I think it's a little important in terms of understanding the power of path array. So we're going to go ahead and we're going to make a spline just like this image over here. So I'm going to type spline, SPL, just like that. I'm going to click the endpoints, just like what we see in the picture. So we basically made this P line just to make a frame. When you're done, press enter. Alright, so it should look just like that, just like the picture. And there's a little bit of a difference in terms of spline. What you can also do is if you type spline, you can say object and click on it. And, only spline fit. Oh, spline method fit object. Method CV object. There it goes. So there is a difference in terms of the spline depending on the method. We're not going to focus on that. I just wanted everyone to see that there is a difference. I'm actually going to move this out of the way because we're going to reuse this later on. Sorry about the little delay. So we're going to use the ellipse tool. We're not going to really use ellipse, but I just want you to see there's other objects that you can draw in AutoCAD as well. Draw an ellipse, about yay big, and now we're going to type in array path. So we're going to select the path curve, which is that, and then this shows up. It's pretty cool, I think. The neat thing about array path, I mean, you can do the same thing. You can change the spacing, to whatever you want. That's nothing really new, but what's cool about this is I can edit the path, and the objects within the array will alter themselves according to the path because they're parameterized with the path. So that's the cool thing about this. And you notice it's working on a curve, but will it work on, let's say, this thing over here? I don't know, what if I have some weird webbing going on? Let's say I have a line here, that long, let's rotate it about -45, mirror it. Alright, so let's say we have this. So I can array path this as well, but on this P line. You see, it kind of follows it. It's pretty nice. It does the same thing. So if I edit the P line, let's say I needed this longer, it would follow it actually. Or if I made this slanted, it would follow it. So that I think is really neat about array path. Again, it's a three-dimensional matrix, so if I put in a 3D view, you can stretch it so it's up the positive z direction. That'll also change it as well. There's a lot of things you can do with array path. You can change, let's see, you want rows, you can say I want 6 rows, maybe I want a few levels. It's, again, super editable. Kind of looks like a little DNA strand, but that's pretty much array path or polar. Excuse me, path array. It just parameterizes objects to a path, whether it's a curve like this or rectilinear, but it has to be a single line, which is why a p-line is pretty powerful. So the next array is actually the polar array, and we'll go over that next time.